Okay, let's get going. We've got f of x is a square root of x plus 2, and we're told that x is any real number, but we have to have x greater or equal to 0. So that's something to be aware of. That essentially means we've got a restricted domain. Now, actually, I think a good idea would be to sketch this function just to get a feel for what's going on. And the square root of x looks like this. That's one that's worth knowing. It's a bit like y equals x squared, but sort of going up the x-axis, but you don't include the negative part. This is strictly positive. And therefore, if you have x plus 2, it's actually a transformation. And you have to translate it back by, or to the, I should say, in the negative x direction by minus 2. And it will look a little bit like this. So I can actually get rid of that red one now. We're interested in the inverse function and to state the domain of this inverse function. Right, well, we have for a function that x is going through this sort of function machine thing or whatever's going on, and we get a y. We have an input, we have an output. The domain is what you put in, and the range is what you get out. That means if you go the other way, for your inverse function, then now this is your domain, and this is your range, but you're mapping back onto x, and therefore these two are the same thing. So all we need to do is find out the range of f of x, and because x is greater or equal to 0, it's going to be here. It's going to be when x is 0, which is going to give us root 2. So I'm just going to write down range of f of x is f of x is greater or equal to root 2. Therefore, domain of the inverse is x is greater or equal to root 2. I hope I've convinced you with that. Now, I've not actually found out what this inverse function is. So I'm going to let y equal root x plus 2. Instead of using f of x, I'm just going to use y. And I want to make x the subject. So it's going to be y squared is equal to x plus 2. And therefore x is going to equal y squared minus 2. That is how you get back from y to x. However, for the inverse function, we always put x in, so we just have to replace that y by an x. So the inverse function itself is x squared minus 2. I should probably just say that x is any real number as well. It's kind of implied at this point, but yeah, I want it there. For b, we have g of x is a quadratic, and we're asked to find the range of g. So it's going to look a little bit like this because it's a positive quadratic, a happy quadratic. And so the key thing is finding the minimum points, and then the range is potentially going to be every value above this, except we again have a restricted domain. So we'll worry about that in a minute. Let's work out where the minimum is. You can't necessarily just put 0 in because the minimum, like it might be that 0 gives you this value, um, or sorry, maybe yeah, and there might be values that maybe this value, and then you can get lower values, is what I'm trying to say. So the first thing to do is complete the square. It's going to be x minus 2 squared by having that 4. Then I need to minus 4 and add 5, so it's going to be plus 1. And so the turning point, or the minimum, is going to be 2, 1. So just draw a little sketch of that. I know it's going to be like here, in fact. Now we just need to look at what happens when x is 0. And we're going to have 5 there. So you can sort of see that actually where is this function actually existing? Well, it's just everywhere apart from here. We don't have this side of it. This is in fact not a one-to-one function. It wouldn't have an inverse. However, it's still okay as a function. So we go down to the turning point and then we go back up. yes, it's greater or equal to 0, but the minimum is 2, 1, and therefore the range is going to be g of x is greater or equal to 1. So yeah, we had 0, we had 5 when we put x equals 0 in, but that was up here. It then comes down to this point here, which is 2, 1, and then back up. Finally, we're asked to solve the equation f g of x is equal to x. Now, there's two ways you can do this. You could actually find out that composite function by substituting in. So you'd have to take your g of x here and put and replace the x here by that. That's absolutely valid. Or you can do the following. You can say that g of x is in fact going to equal the inverse of f of x. So essentially I've applied the inverse function to both sides. So now I can write down that x squared minus 4x plus 5 is equal to x squared minus 2. I can cancel out the x squareds, so I'm going to get that 4x is equal to 7, and therefore x is going to equal 7 over 4. Now I think there's just one thing I need to be aware of. Well, I'm finding f of g of x, remember, so we just need to check like that this is valid because g of x is only valid for x is greater or equal to 0. So that is okay. Um, and then we just need to check that it's also okay for f of x. Now we had that f of x was, well, the domain was that it's greater or equal to 0. And when I put 7 over 4 in to g of x, I will in fact get that. You can try it and see. And then we know that the range is going to be greater than or equal to root 2, which is about 1.4, which this thing is. So I'm just sort of checked it. I don't think this question is going to try and catch you out because there's only one solution. It's not like you're then going to, say, oh, actually there are no solutions. But it is good because in principle, it might be that there are no values. Anyway, that's what the answer is, and that's the end of this question.